In this video, we have the integral of natural log of x squared plus 49. Normally, you want to try either u substitution, some kind of u substitution, or integration by parts. We had an x here in front, it would work fine. X times any constant. So in this case, I don't want to let u equal to x squared plus 49. So we're going to try integration by parts. So we want to find u, something we can differentiate. Sometimes it's difficult to integrate the function natural log, but it's very easy to take the derivative of it. So let's write this. Let's set u equal to natural log of x squared plus 49. Then du will simply be the derivative of the natural log function, which will always be the derivative of the argument here, which is derivative is 2x. Derivative of constant 49 is 0, and it's always over whatever that expression is. In this case, x squared plus 49. And that's your dx here. And then your dv will be something you can integrate. So we have one thing we have left is a dx or a 1 dx. You can always let dv equal to that. Then we integrate here with respect to v on the left side, with respect to x on the right side. That'll just give me a v equal to x. Now once you have your u defined, in this case, the integral of the original expression will be uv. So we have u right here and v over here. So it's always the product of u and v. That's part of the answer, and then minus the integral of v du. That's your formula for integration. That's your general formula. Other forms of it, but this is the more popular one. And now we're set here. So we'll say this is equal to u is this expression here. So that's going to be ln of x squared plus 49. And that times v. U times v right here. And I'll put the v out in front. That's x. So that's going to be x right there. And then it's minus the integral of v du. Well, v is just x. So this will just be an x here. And then du is right here. So this will be then times the 2x, and then we got x squared plus 49, and then got a dx here. And then this is equal over here then. Again, we have the answer there. First part of the answer, x ln x squared plus 49. Again, we're using integration by parts here. And then it's minus, let's multiply these out here, 2x squared. It's the integral of 2x squared dx over x squared. This is supposed to be 49 here. And then this is going to equal over here then. This will equal to, now what I'm going to do here, you have the integral of 2x squared over x squared plus 49. You think, well, right here we could probably use partial fractions. But you always want to simplify if you're dealing with partial fractions. Degree of the numerator is 2, degree of the denominator is 2, so I'd have to simplify that. So what I'll do here, I'll simply divide, use long division here. So 2x squared divided by x squared plus 49. So 2x squared, long division here, will be divided by x squared plus 49. So x squared into 2x squared goes 2. Then 2 times x squared is 2x squared. Then 2 times 49 is 98. And then we subtract here. So these cancel out. 2x squared minus 2x squared cancels, and then this is 0 here. So 0 subtract 98, that's a minus 98. So then I continue over here. This is x ln of x squared plus 49 minus, and then this is going to be the integral of So I'm going to replace this integrand here with what I got here. So 2x squared divided by x squared plus 49 gave me a 2. So I'll put this out in front or inside here 2. And then it's minus 98, so it's going to be minus 98. I could make it plus, and then I'm minus 98 over the x squared plus 49. And I could break this up into two integrals. I'll leave it right now. I have it as 1, like that. Or I could just integrate and say, okay, it's the integral of 2 with respect to x, and it's the integral of minus 98 over x squared plus 49 dx. So let's just do it this way. Equals 2 again. I'm just recopying the same thing again. And it's ln, close parentheses here, x squared. So it's x natural log of x squared plus 49. And then right here, then again, I'll distribute this negative here. So it's going to be a minus 2, and we're integrating with respect to x. So that'll give me minus 2x. And then let's distribute the negative over here. I haven't taken the integral of this part here, so this will be plus. This negative distributes over there. And then I'm going to leave that 98 out in front of the integral. This will be 98 minus minus, so I got the positive there. And it's the integral of, and this will be the dx, or 1 dx if you want. And that's over x squared plus 49. Now I've used this formula that I'm going to use right now on several videos here. You can derive it, and I actually derived it in another video I did using a trig substitution. But it's this formula right here. Anytime you have the integral of du, where u will usually be a function of x, du over u squared plus a squared. Anytime you have anything that looks like this, now it could be, you could have a constant right here like a k, same thing. The answer would just be multiplied by k, but it gives you the tangent inverse or arctangent. I'll divide it as tangent inverse, so it's tangent inverse of whatever u is. See, this is in the form u squared plus a squared, whatever u is over whatever a is, and then the coefficient here is multiplied by 1 over a, and then it's plus your constant of integration. So that's the formula that I'm going to use here. So again, just rewriting the same thing again. X ln x squared plus 49 minus 2x, and then this right here is the same formula that I just wrote over here. Instead of u squared, I have x squared. So it's going to be plus, and then it's going to be tangent inverse of u over a. Now in our case, u is x, so it's going to be x. And a squared here is 49, so a would be 7. So this would be tangent inverse u over a is 7. And I got the constant of integration. And then whatever coefficient you have here is divided by a. So this would be divided by 7, which would give us 14. So the final answer then would be x natural log of x squared plus 49 minus 2x plus 14 tangent inverse of x over 7 plus the constant of integration. Thanks for watching. We'll see you there next time.